Hey, can you guys hear me? Okay, looks like you figured out the QA app. Okay, if we convolve an image with a first derivative of Gaussian filter, should it be? Um, yes. Yes, you should. So, yeah, the answer to that is, not sure if you guys can hear me yet. Hey, if somebody's able to see this or hear this, could you type into the all chat and also let people know about the new link? Somebody? Hello? Hello? Can anybody hear me? If you can, please type into the all chat. Seems like some people aren't able to use this. If you're just arriving, if you can hear me, could you please type into the all chat just to confirm that this is working? Hello? Can you guys hear me now? Okay. So you guys can hear me. I'm not sure. Oh, okay. Now I see you guys are all posting in the all chat. Okay, cool. So uh, I did respond to Kate your question at one point. I'm not sure if you got that or not. Uh, okay, hold on. I'm going through these questions. And you were asking about the Sobel operator. Okay, so the Sobel operator, um, it is the computation of the gradient in x and y, and you um, rotate it depending on whether you're computing the gradient in the x and y or x or y. And good question about all chat. I don't know if you guys can see it or not. I have access to it on the left-hand side of my screen. This is the first time I've used this, so um, okay. Does the Sobel operator approximate the first derivative of a Gaussian function? So it's I don't know that I would say it approximates the first derivative of a Gaussian function. It's the gradient in either the x or the y direction. So it's more like a partial derivative of whatever image you give it. I hope that answers your question. If not, please post again. Sean asks, since we are waiting around, can you step us through Harris Corners and tips to implement it? Okay. Um, Harris Corners. Give me a sec, guys. Still dealing with people not being able to use this for whatever reason. Okay. Um, it's actually not working quite as well as WebEx, oddly. Harris Corners. So your first step when you're finding a Harris Corner, you're going to want to set a Gaussian. You want to set a window that's it's typically 5 by 5. I think is usually the standard. Um, then using that window, you're gonna uh, first compute the gradient of the image. You don't actually need a kernel for that. Uh, well, other than the Sobel operator, you don't need a window, is what I mean. Um, then when you actually find the Harris corners, you're going to want to apply that window so that for both your x and your direction, your x and y direction, and what you're doing is you're essentially squaring the gradients and you're taking a weighted sum within that window. Then you are going to compute the determinant of these two windows that you've now squared, right? Or not the windows, the outputted functions. You're going to compute the trace of these two, right? So you've got your determinant is going to end up being the gradient squared in the x direction dot multiplied with the gradient squared in the y direction. And then your trace is going to end up being the gradient x squared plus gradient y squared. Then you're going to set some kind of alpha, which is generally way below 0.1. And using that, you're going to compute the Harris value for your image. And that is going to be the equation, which I believe you guys already have. Okay, so I'll get back to that if that wasn't good enough. And next question, chew on. Okay, yeah, so I saw your question, and I honestly was not 100% sure what you were actually asking. But I did think about it, and I think I can give you a little bit of an explanation that may help to clarify some of those issues. Um, so your question was about, let's see. Your question was about the line fitting, and whether or not like what the x's and the y's are. And I think somebody responded that the x's are basically the descriptors and y's are the label. So essentially, your x's are what you're looking at, what you have, and then your y's are what are outputted. And the y's are essentially labels that give you a description um, that categorize your information, right? So you have some kind of function, you input data x, and at the end you end up with y, which labels, which is going to place your data point into one category or the other. And also the t that you asked about before is in fact the function itself. And I guess we can get back to that if you have more detailed questions. Other people are already saying, I see that they would rather be using WebEx, and I kind of have to say I sort of agree because this is not working very well. Okay, and Kate, you asked the Sobel kernel, does it approximate the first derivative of a Gaussian? In other words, does it do smoothing when it returns the gradient? Oh, I see what you're getting at. So depending on what kernel you're using, and depending on the actual function calls, I believe you guys, see when I did this was in MATLAB, but I think you guys are implementing all this probably using NumPy or something else like that, where you're making your own kernels. So does it approximate the first derivative of a Gaussian? Yes and no. When you're gonna want to use a Gaussian anyway to be able to control the amount of blur that's actually applied, so how much smoothing actually is done. Um, if you use a if you just use the Sobel kernel, you're not going to be able to control that very well unless you modify the individual values, or if you multiply it, which I guess you could do. But you're going to have a little bit more control with the Gaussian function to begin with. So uh, no, it does not do smoothing in the way that you're probably thinking. You're going to want to be able to control it a little bit better. And yeah, essentially, no, it doesn't really do smoothing like that. It's really more it since it's performing that operation to every single part of the image, it's not going to, let's see, like it's not actually performing a smoothing operation, I guess, is just the simplest way I can put it. If that doesn't fully answer your question, I guess get back with me. Can further problem sets starter code be EP8 compliant? That's a really good question. So honestly, we didn't even have these before. This is a brand new thing, those starter code things. In terms of PEP8, if you could, I don't know, I mean, this is probably not the right place for that, but if you could maybe email us or make a thread on Piazza or, yeah, probably emailing would be best actually. And just point out some specific things. I honestly haven't even looked at the original templates yet, but I can only imagine. This whole thing of making it Python exclusive is brand new to the semester, so just trust, bear with us. Trust me, I understand that everything is not in order. So I would hate to move this again for this office hour. Um, but next time we're definitely not going to do it this way because I would rather hear from you guys more, and this does not allow that. So I apologize for this. This is not an ideal situation. I don't think you guys can even access the chat, which is not good. Um, I also can't tell who's on, so yeah. If you have any other more, if you have any other questions, please just go ahead and post them. Okay. Well, I guess I'm glad that it's not completely terrible. I've had to do some Python stuff before too, production level work, and trust me, I understand when people don't format it properly. It's really annoying. Some ground truth images for PS5. Um, if you haven't already been provided those, I kind of doubt it. Which ones specifically? Oh, just in general, what is your output supposed to look like? So, which maybe be a little bit more specific. I'm I'm not convinced entirely that you guys don't have access to the chat app. If I go to the left hand side of my screen there is a menu that pops up, and one of the options is chat. If you guys could talk in that, that would probably be better. I'm displeased with this setup. It's not working very well. Okay. I think it would be useful to have more expected results and maybe tests. Expected output F was really helpful. Yeah. Yeah, I understand. This problem set in particular, I'm just gonna go ahead and say is it's pretty difficult. And people always have a lot of very individual issues with this one in particular because it involves like things where you could use all sorts of different methods, especially the randomization part. And also, yeah, I mean, you're going to get some wacky outputs before you start getting stuff that makes sense. I will talk to the other TAs about that though. And we have questions showcase. Yeah, unfortunately, this thing seems pretty restricted. I don't have a whole lot of control over what you guys can see. I like sincerely apologize about this. This is not working out very well. I thought it would be a lot better. Um, let's see. Maybe there's some kind of app I can add. No. So the transformation is the line. How does that select and what are the good matches? Okay, so the line itself actually um, doesn't do that on its own. Um, and I'm assuming you're mostly talking about uh, Sift in particular, since that's what you guys have to use. Um, I think it's a little confusing because the way Bobak explains it in the lectures is that essentially, you have a line, right? And that's your function. Well, that's not totally true. I mean, it is in the simplest sense, but you have to imagine that like you got a ton of data points. So it's not like you're going to be thinking about this as like a linear, function. This is a function that's based on the image. And so if you look at the included documentation, which should be, yeah, it's included in problem set 5. It explains how to use SIFT, and I think that should help explain. I'm not sure if you've looked at that yet, but essentially, um, what you're doing is you want to find things that are the same in both images, right? That's your goal. Your goal is to find both things that are features that are interesting, right? So that's where you've got your Harris corners. It's why you're computing gradients. The next step uh, is that you're going to um, match those features, those important points, and you're going to do that using the SIFT operator. And then eventually you're going to run those through Ransack, and those are going to translate from your descriptors back to the image that you had. So I don't know if that helps at all. I was hoping that's helpful. And yeah, Sean, I totally agree. That's exactly what I'm going to do next time. I would do it now, but I think too many people are already expecting this, and I'm sure I lost a lot of people transitioning from one thing to the next. So, um, yeah. Yeah, I haven't tried this broadcast thing before, and I have to say I'm disappointed with the features. I thought it was going to be a lot better. There's another class using this semester, and um, it I don't know, it worked out pretty well for them, but it's different for this class. Also, Kate, I don't know if you're still there, but I kind of misspoke. The Sobel operator does find the first derivative of a Gaussian, so it does have smoothing in it. But I just wanted to make sure that you weren't relying on that. So I was saying, that you can't control it very well. So if anybody else has questions, post them now. I'm again sorry that this turned out to be so bad. Yeah, yeah, definitely not going to do. Shuan, I'm already 2 steps ahead of you. I got my WebEx already rolling. So if you guys want to go ahead and go to the WebEx, by all means, just go ahead. I'm going to post on Piazza. I'm going to post a link here because, yeah, this is lame. So I'm already on there. So if you guys want to go ahead and log into WebEx, I'm there.